moments about mean, moments about any point, there is a factorial moments and there is absolute moments. So just we define the factorial moment and absolute moment, then we try to discuss about the properties of moments. So what is the factorial moments? How we define the factorial moments? So like moments about any points, moments about mean, there is a concept of factorial moment. Factorial moment. So what is the notation of factorial moments? Notation of a factorial moment is this one, mu or this one inside the bracket r, we write inside the bracket. Here we define the factorial moments about origin. So this one is what? 1 upon n summation of fi xi to power what? Here we write a factorial notation r, bracket r. And what is the value for here? Here is factorial moments about origin. Here we try to write means the value for a is what? The value for a is 0. So what is the value for xi to power r, where xi to power r is what? Xi, here xi to power r is xi minus 1, x minus 1, x minus 2 up to what? X to power r, not here we write I, here we write x to power r. X to power r is x minus 1, x minus 2, x minus 3 up to x minus r plus 1. X minus r plus 1. So this one is a what? Mu r. So this one is a factorial. Now if we write what? If we write mu 1, so what is the value for this one? Mu 1, mu r, basically this one is not a mu r dash, we write what? Because this one is a, sorry. So notation is not a mu r, this one is a mu r dash. Mu r dash equal 1 upon n summation of fi xi to power r, where x to power r, x factorial notation r, meaning of this one is x minus 1, x minus 2 up to x minus r plus 1. So in terms of factorial, what is the mu 1 dash? Mu 1 dash 1 equal to what? 1 upon n means what is the value for r? R is a 1. So 1 upon n summation of fi xi to power what? 1. And if this one is a 1, r is a 1, so how we write the value for x? X become r is a 1, so this become minus 1 plus 1. What is the value? This become 1 upon n summation of fi xi, and moments about origin is a what? 1 upon n fi xi equal what? Mu 1 dash. So factorial moment, first factorial moment equal to what? Moments about the origin, first moment about the origin. Similarly, we write a mu 2 dash, then this one equal 1 upon n summation of fi, and this become what? xi, and this will become what? R equal what? R equal 2. So this become what? If we write like this way, so 1 upon n summation of fi, and this become what? This become xi summation of, sorry, xi minus 1, xi minus 1, because the value for r become what? R become 2. So r become 2 minus 2 plus 1, this become minus 1, so x minus 1. So if we simplify this one become 1 upon n summation of fi. If we multiply this one, then this become what? xi whole square, xi square minus 1 upon n summation of xi fi xi. So if you closely observe, this one is a what? This one is a mu 2 dash. So mu 2 equal what? Mu fact in terms of factorial notation, mu 2 equal mu 2 dash mu 2 dash 2. So this one is not a mu 2 square, this one is a mu 2 dash minus what? Mu 1 dash. Mu 2 dash minus mu 1 dash. So this one is a what? This one is a mu 2 about origin, moments about origin, moments about any point, moments about origin means the value of a is a 0. So this one is a value of a mu 2. Similarly, we find a mu 3, mu 4 factorial in terms of a factorial notation. Similarly, absolute moments, or we define the absolute moment. Absolute moment. Absolute moment. So absolute moment is denoted like this one and defined as denoted by mu fact absolute value for this one. This one is a notation. How we define? This one is a 1 upon n summation of fi mod of xi minus x bar to power what? R. Xi minus x bar modulus value of this one xi minus x bar to power R. So this one is a what? This one is a absolute moments. So absolute moments where R is a what? R ranges from R equal 0, 1, 2 and so on. So this one is absolute moment. Similarly, factorial moment, there is a absolute moment. But in general, we discuss about the what? Moments about any point and moments about mean. So next we are going to discuss some properties of what? Some properties of moments. Then we define about Pearson coefficients called Pearson coefficient, which is based on moments. Then we properties of I am not going to discuss very detail of the properties of moments. Just we discuss about one property means what is the effect of change of origin and scale in a moment. So if we talk about change of origin and change of scale in a moments, so moments about any points, if we talk about moments about any point, or if we talk about here properties, first one, effect of change of origin and scale. Change of origin and scale. So suppose here we denote this one is a not here mu, if we write a what? U equal capital U equal, this one is a U equal x minus a to power x minus a upon h. U equal x minus a upon h means there is another variable in term of what? In term of x, here we write what? U. Then here we try to examine what is the effect of a change of origin. Here we use the change of origin is what? Capital A. For sake of simplicity, here we take a like moments about any points. So this one is what? H, change of a scale. Now what is the effect of this one? So if we write x minus a equal what? X minus a equal UH. So and what is the value of x bar? And if we take a summation of this one, then this becomes x bar minus a equal h u bar. And what is the value of x minus x bar? If we write here, subtract these two, then x minus x bar equal h u minus u bar. U minus u bar. So we use these two results. This result means suppose this one is first and this one is second. So now we try to put these values and try to check what is the effect of change of origin and change of scale in moments about any points and moments about mean. So what is the moments about any point? Any point mu r dash equal 1 upon n summation of fi xi minus a to power what? R. Xi minus a to power r. So mu r dash equal what? Mu r dash, and if we try to differentiate this one, mu r dash in term of x. So here we write not a mu r dash. If we write what? If we write a mu r dash in term of what? In term of x. Mu r dash in term of x. Now, what is the value for xi minus a? Xi minus a is a ui h. So, what is the value? This become what? This become 1 upon n. 1 upon n summation of fi. What is the value for xi minus a? Xi minus a is a ui h to power what? R. Ui h to power r. So, this one become what? H to power r outside. This become 1 upon n summation of fi ui. This one is ui to power what? R. So this one is what? This one is a moments about origin. So moments about origin will be denoted by this one is a mu r dash in term of x. This one is this one, and this mu r dash x equal what? S to power r, and this one is a mu r dash in term of a u. In term of a u. So we say that this one become what? This one become mu r dash in term of x become s to power r mu r dash u. So similarly, what is the value for if we write mu r in term of x in a what? In a term of means moments about a mean. So what will happen here? 1 upon n summation of fi xi minus x bar to power r. So xi minus x bar, if we closely observe this one is xi minus x bar equal h ui minus u bar. So here this become 1 upon n summation of fi h ui minus u bar to power what? R, h to power what? R. So h to power r is a what? Constant. So this become what? Outside. So this become h to power r outside 1 upon n summation of fi ui minus u bar to power r. So you may also write this one h to power r, and this one is a what? This one is a mu r in term of a what? In term of a u, and this one is a mu r in term of a x. Mu r in term of a x. So this one is a means you may say this one is a moments about a mean is independent from the origin, but this one depends on a change of a scale. So moments is independent from the change of origin, but this one depends on the change of a scale. So this one is a effect of a change of origin and scale. Now one of the things that we define here means which is based on a moments means Carl Pearson defined four coefficients. Four coefficients, and name of these coefficient means nomenclature of these coefficient is a beta 1, beta 2, gamma 1 and gamma 2. So Pearson's coefficient here, if we write a Carl Pearson coefficient, Carl Pearson coefficient, cos Pearson coefficient based on moments. Carl Pearson coefficient based on moments. So he defined what? He defined a beta 1 equal what? Beta 1 equal mu 3 square upon mu 2 cube. This one is a what? This one is a value for beta 2. Mu 3 is the what? Moments about origin. And mu 2 is the what? Third moment about mean, and mu 2 is the second moment about mean. And define a gamma 1 equal plus positive value of root of a beta 1. Similarly, he defined what? Beta 2 equal what? Mu 4 upon mu 2 square. Mu 4 upon mu 2 square. Once we verify this one is the correct one or not. This one is mu 4 mu 3 square upon mu 2 cube. Okay, so this one is the correct one. So beta 1 equal mu 3 square upon mu 2 cube, gamma 1 equal plus under root beta 1 and gamma 2 equal beta 2 minus 3. Beta 2 minus 3. Later on we use this coefficient, means beta 1 to decide the lack of a symmetry. Either there is a symmetry or not. Lack of a symmetry means a measure of a skewness. And we use the beta 2 to decide the measure of a kurtosis. So later on so this one is a Gauss-Pearson coefficient based on moments, means we use the beta 1, beta 2, gamma 1 and gamma 2. So what we are going to do here, so okay, now we solve one numerical example, very simple numerical example, means how we find the first 4 moments for the given data. So this one is a problem, find first 4 moments about mean, means we try to find out the values of mu 1, mu 2, mu 3, mu 4, not mu 1, mu 2, mu 3, mu 4, and here what is the given? Here there is a 5 data, means x and f, 2, 3, 4, 5, 6, 1, 3, 7, 3 and 1. So here to find out means here we find f into x. F into x is a what? Here we find f into x. This one is a 2, 3 is a 9, this one is a 28 and this one is a 50, this one is a what? 6. Because here what is our aim? Our aim is to find out what? Mu 1 is already a value, mu 1 equal what? 1 upon n summation of fi xi minus x bar, and we know that what is the value for this one? The value for this one is a 0. And mu 2 dash equal 1 upon n summation of fi xi minus x bar to power what? 1, 2. So this one equal, here we try to find out this one. Similarly, mu 3 equal 1 upon n summation of fi xi minus x bar whole cube, and mu 4 equal 1 upon n summation of fi xi minus x bar to power 4. So here there is a need to find out xi minus x bar whole square, whole cube, whole to power 4. So first we find the x bar. What is the value of x bar? And we know that what is the value of x bar? X bar equal 1 upon n summation of fi xi. So what is the value of fi xi? This one here 2 1 is 2, 3 is 9, 4 7 is 28, 5 3 is 50, 6 1 is 6. And what is the value for this one? Summation of fi xi? 9 to 11, 11, 6. 9 to 11, 11, 28. This becomes 39, 39, 39 and 15, 49, 49 plus 5, this one is 54 plus 6, this one is 60. And this one is, what is the value for this one? 4, 7, 4, 11, 3, 40 plus 1, this one is what? 15. So what is the value of x bar? X bar become what? X bar become 60 by 15. What is the value for this one? This one is 4. So here first we find what? First we find x minus x bar, means x minus 4, x minus 4, x minus 4 whole square. This one is a z. We denoted this one is by the z. This one is a what? Z square. Z square equal x minus 4 whole square. Z cube equal x minus 4 whole cube. Whole cube. So this one is a what? Whole cube. This one is a whole cube. So here there is a need to, also there is a need to find out the what? The value of a z to power 4. So here we find a z to power 4 also. So what is the value of a z? Here we write it the value of a z. Means this one is a x minus 4. 2 minus 4, this become what? Minus 2. 3 minus 4, minus 1. 4 minus 4, 0. 4 minus 4, because mean is a what? Mean is a 4. 5 minus 4, 1. 6 minus 4, this one is a what? 2. So, this one is a, this one. What is the value for? Here, basically, there is a need to more values. So, here, basically, we write some more values. So, rather than to write this one, okay. First we write this one, then we try to multiply this one. So, this one is a what? This one is the value for z. What is the value for z square? Z square, if we write in term of a what? In term of a not here, this one is a z, then here we write a z square. Z square, here we write a z cube, here we write a z to power 4. So, what is the value for square of this one is a 4. 1, 0, 1, and this one is a what? 4. And cube of this one is a what? Minus 8, and this one is a minus 1, this one is a 0, this one is a 1, and this one is a what? Plus 8. This one is a plus 8. So, and what is the power of the z to power 4? Power of 4 of this one is a 16, and this one is a 1, this one is a 0, this one is a 1, this one is a 16. So, z to power 4. So, now there is a need to what? There is a need to find out the value for fz square. F into z square. F into z cube. F into z to power 4. Means these values also. So, these values also. So, here if we write not here. So, if we write here more space, if we make a more space here, then this one become what? Then this one become fz square, fz cube, fz to power 4. Fz to power 4. So, now here if we write the summation, so here if we write this one in this way, and here we write in this way. So, f into z square. So, 2 into 4, this one is a what? 8. 8. 9 into 1, this one is a 9. 28 into 0. 28 into 0, this one is a 0. And 15 into 1, this one is a 15. And this one is just, sorry, not a 15. Something going to wrong one. This one is a f is multiplied by this one column. This one is a column multiplied by what? This column multiplied by the z square. Z square. So 1 multiplied by 4. This one is a 4. 3 multiplied by the 1. This one is a 3. 7 multiplied by the 0. Then this one is a 0. 3 multiplied by the 1. This one is a 3. 1 multiplied by the 4. This one is a 4. So now next one is a next one we multiply f by the z cube. So 1 minus 8, this one is a minus 8, and 3 minus 1, this one is a minus 3, 7, 0, this one is a 0, and 3, 1, then this one is a 3, and 1, and this one is a 8, this one is a minus 8, this one is a plus 8. And if you multiply it by the last one means here we also write in this way. Last one, f1 into 4, this one is a 4. So 1 into 16, this one is a 16. 3 into 1, this one is a 3. And 7 into what? Z cube. So 7 into 0, this one is a 0. And last one is a 1 into 16, this one is a 3 into 3, this one is a 3 into 1, this one is a 3. And 1 into what? 16, this one is a 16. So these are the values. So if you find the sum of these one, so if you closely observe, minus 2, minus 1, minus 3 and plus 3, this one is a what? 0. What is the value for this one? There is no need to find out these values. Only need to find out the value for fz square, fz cube, fz to power 4. because z is a what? Z is a x minus x bar. If we write this one is x minus x bar. So what is the value for this one? Fz square 4 plus 3 7 7 7 40, and this one becomes 0. And what is the value for this one? 16 3 19 16 3 19 19 19 30. Now this one is all about. So what is the values? Values become what? Mu1 equal what? Mu1 equal say mu2 equal what? 1 upon n summation of fi xi minus x bar whole square, and this one equal what? 1 upon n summation of fi zi square. What is the value for fi zi square? This is 40. So, and what is the value for capital N? Capital N is a 50. So this become 14 by 50. This one is the value for what? This one is the value for mu2, and if we simplify this one is what? 0.933. This one is the value for 14 by 50. Now what is the value for mu3? Mu3 equal 1 upon n summation of fi zi cube. Zi cube, what is the value for fi zi cube? This one is a 0. So what is the value for this one? 1 upon 50 into 0. What is the value for this one? 0. Similarly, what is the value for mu4? 1 upon n summation of fi zi to power 4. Zi to power 4. So what is the value for zi to power 4? This one is 38. So what is the value for this one? 38 divided by 15. What is the value for this one? This becomes 2.533. So this one is the value for mu1, mu2, mu3 and mu4. So if we talk about the beta 1, what is the value for beta 1? Beta 1 equal mu3 square upon mu2 cube. What is the value for mu3? Mu3 equal what? Mu3 equal 0. So what is the value for beta 1? Beta 1 0 upon whatever the value. So beta 1 become what? 0. Because the value for mu3 equal what? Mu3 equal 0. What is the value for mu4? Sorry, not a beta 2. What is the value for beta 2? Beta 2 equal mu4 upon mu2 square. If we put the value for here, mu4 upon mu2 square, what is the value for mu4? Mu4 equal beta 2 equal 2.533 divided by mu2 square. What is the value for mu2 square? 0.933. 933 whole square. So if we simplify this one, what is the value for beta 2? This one becomes 2.91. Similarly, what is the value for gamma? Gamma equal under root mu2. So what is the value for gamma under root mu2? Under root mu2 is what? Mu2 is a 0.93. So what is the value for this one? This one is a 0.966. So this one is a procedure how we find the values of mu1, mu2, mu3 and mu4. So this one is all about this lecture. Thank you for watching my video.